Seventh graders, welcome to the mini unit here in Unit 5 titled Inequalities. Our first lesson, as you already read, is 5.6a. And our goal today is to be able to define the word inequality and then to graph an inequality involving positive and negative rational numbers. Let's start with defining that word inequality. Let's go back, and if you were here with us in 6th grade English, we worked on prefixes, suffixes, and the roots of words. So I want you to look at these words I'm going to put in front of you, and let's talk about the meaning. So we have the word incomplete. It has the prefix in. In there is telling you it's the opposite of complete. So incomplete is not complete. Look at the next one. Insecure. Well, secure means I'm comfortable. I feel confident in what I'm doing. So if I'm insecure about something, I'm not confident in what I'm doing. I'm not comfortable. So again, the prefix in means not. Let's look at another one. Inconvenient means, well, not convenient, not easy, not helpful. Another one, inaccurate. Well, it would be the opposite of accurate, not accurate. Not correct is another way to say that. So what about the word inequality? That's part of our goal today, to be able to define it. Well, we know in, the prefix there means not. And then look at the other part of the word. Do you see the root word in there? Equal. If we put in front of that, inequality means not equal. Look at that first chunk in your notes. Let's fill that in. Inequality means it's the relationship between expressions that are not equal. We've been working a lot with equations, so it's the opposite almost of an equation. We have 4 inequality symbols that we are going to focus on this year. There is another one, but we're not going to focus on that one this year. So in the first column in the chart, put this inequality symbol. You've seen it before. What's the name of it? Is greater than. A lot of times we'll just say greater than, but we need to be careful because greater than could imply that we're adding. And in here, we're talking about an inequality symbol. So we need the word is greater than, that linking verb actually there to help us. Here's the other symbol. Go ahead and write or draw this one in the second column. Do you have an idea of what the name would be for this one? The only thing that's different is this time we have what appears to be a line underneath the is greater than sign. This inequality symbol is read as is greater than or equal to. So it has half of an equal sign in there. Here's another one. This one we've used a lot. It's the is less than inequality symbol. And then I bet you're already inferring what the last one is going to be, but I'll give you a moment to write that is less than in or finish up writing the other ones. Less than or equal to. These are the 4 inequality symbols that we are going to be working with in this mini unit. If you need to, pause the video and make sure you have everything that's in my chart in your notes. Looking at the second chunk in your notes, our job here is to list at least 5 solutions for each inequality. Looking at number 1, we have, I would read this from left to right, x is greater than 4. So I'm thinking in my head, I could put in any number for x, but in order for it to be a solution, I would have to read it as it's greater than 4. So can you think of a number right now that's greater than 4? How about 5? If you plug 5 in for x, would that be true? 5 is greater than 4? Yes. Remember, we read from left to right. What would be another value that you could plug in for x that, when you read it, it would be greater than 4? How about 6? What's another one? 7? 8? 9, we could go on for forever because our numbers go on for forever. So any value that is greater than 4 is a solution to the inequality x is greater than 4. Remember, an inequality is where a relationship is being expressed, and it doesn't have to be equal, but the numbers still have a relationship to one another. And the relationship here is all of our solutions are greater than 4. Make sure you have those numbers written on the lines in your notes. Let's look at the second inequality. How would we read it? Remember, we read from left to right. Look at that inequality symbol. What is that one? Find it in your chart in the first chunk. less than or equal to. So we would read this as x is less than or equal to 7. We're looking for any values that we can plug in and relate to 7, but would satisfy this inequality, meaning it's less than or equal to. Well, could we plug anything in that would be equal to 7? How about 7? Yeah, 7 is equal to 7. Now I'm looking for values that would be less than 7. And you might go, Mrs. Kluber, I thought that you said inequalities are not equal. Well, yes, those words did come out of my mouth, but the main thing is that inequality is a relationship between numbers that are not equal. So yes, you might have a value that you can plug in here and you would say it's equal to 7. But then there are also other values that are going to be a solution to this inequality and they're not equal to 7. They just need to be less than. So what would be a value I could plug in here since I already found the one that's equal to? I could plug in 6. 6 is less than 7. What's another one? 5. How about another one? 4. 3. We could go on for forever, right? Because there's an infinite number of rational numbers that are less than 7. But remember, this inequality symbol is saying whatever you plug in is less than or equal to 7. So you have kind of an extra relationship piece there. Let's look at the third inequality. How would we read it? X is less than negative 11. So here, I'm not looking for a value that's equal to negative 11. I'm looking only for values less than negative 11, and I'm relating them to negative 11. What could I plug in? Remember, when you have the minus in front of it, you got to think opposite. It's further away from 0, so I'm looking for a value that's going to be less than negative 11. Negative 12. If I plug in negative 12 for x, is negative 12 less than negative 11? Yes, it is. What would be another one? Negative 13, negative 14, negative 15, negative 16. There's an infinite number of rational numbers that I could plug in for x, but they have to be less than the negative 11. That's what I'm relating it to. So when it comes to thinking about solutions for inequalities, we're taking values and we're substituting them in for the variable and making sure that it's an appropriate value to what the inequality symbol is saying. Going to the third chunk in our notes, if we look over on the left-hand side, it says, how do you graph inequalities? So we started today with talking about what an inequality is, a relationship between expressions that are not equal. We looked at the inequality symbols, the 4 of them that we're going to be using. We talked about solutions for inequalities and how it might be confusing because we're saying inequalities, you hear the words not equal, but yet we have inequality symbols where it's less than or equal to, greater than or equal to. Main thing to remember, inequalities are a relationship between values. So going to the third chunk here, we're going to graph inequalities. It's a way to see inequalities. Remember, math is a language and we're constantly translating and working with this language to understand it more. Looking at number 1, let's refresh our mind. How would we read this? We read from left to right. X is greater than or equal to 2. So now any value we plug in for x, it can either be equal to 2 or show that it's greater than 2. Let's start by finding 2, that rational number on the number line. Now we're saying any values we plug in for x could be greater than or equal to. So think about this number line. I need to show that it could equal 2. So I'm going to color in my dot on 2. Did you see that? Color in your dot on 2 right now. Make it big, like mine in front of you. And now any value that we plug in for x, while it could be 2, it could also be greater than 2. What would be a way to show that on a graph? Well, I'm talking about all these numbers to the right of 2, including 2. What about if we just did an arrow pointing right? And our arrowheads mean that it could go on forever. Here is the graph of the inequality. X is greater than or equal to 2. My circle on 2 is filled in because x could have a value of 2. My arrow is going to the right because I'm talking about all the values that are greater than or equal to 2. And if you think about it, do you see the x here in my inequality? And then this inequality sign is like an arrowhead. It's pointing to the right. And that's where my arrow is pointing on my graph. Let's look at the second one. Practice reading it. X is less than or equal to -3. Here's my sign. I'm saying that any value I plug in for x could be less than or equal to -3 for it to satisfy this inequality, for it to be a solution to this inequality. Let's start by finding -3 on the number line. And is it going to be a closed dot on -3? Am I saying x could equal -3? I am. So I'm going to color in my dot on -3. Do that in your notes. And now any value I plug in for x could be less than or equal to -3. So now I need to show values less than -3. That means I'm looking at all these rational numbers to the left of -3. So I'm going to point my arrow that way. Here's the graph of the inequality x is less than or equal to -3. And if you think about it, do you see x here? Here's my arrowhead. Is my arrowhead on the graph pointing the same way as my inequality sign? Yeah, so that's a quick check to see if you did the graph correctly. In that chunk on the bottom, you have a sentence to fill in. For less than or equal to, write that in, or greater than or equal to, we need to use a closed circle, right? A closed circle on the graph because we're saying the value we plug in could also be equal to the value of where our point is on the graph. Any questions that you have here, go ahead and write them on the left-hand side and make sure you ask when we connect together. Let's go to the next examples, 3 and 4. Flip to the next page in your notes. We are still graphing inequalities. Notice how the inequality sign has changed this time. Looking at number 3 here, we have the inequality x, read it with me, is greater than 2. So any value I plug in for x, it needs to be greater than 2. Let's represent that on a graph. Start by finding 2 on the graph. Now, am I saying that x could be equal to 2? No. So this time I'm not going to close the circle in. I'm going to leave it as an open circle because I need values that are greater than 2. If I need values that are greater than 2, it can include 2. That's why I'm not coloring in the circle. I need my arrow to be pointing to the right. And look at this. My x is coming first, and look at my inequality symbol. It's like an arrowhead, and is it pointing to the right? Yeah, it's matching my arrowhead over here on the graph. So another fun little trick to make sure you graph correctly. Here's the graph for the inequality. X is greater than 2. Going to number 4, let's practice reading this one. X is less than -3. So we're looking for values that are less than -3. Let's start by finding -3 on the number line. Am I saying the value could equal -3? No. So it's going to be an open circle on -3, and I'm talking about values that are less than -3. So all of these to the left, I'm going to show that with an arrowhead. And let's use our trick. Here's my variable first. Look at my inequality symbol. It's pointing to the left, and so is my arrowhead on my graph. I graphed it correctly. Let's fill in the sentence below. You do it in your notes as well. For less than or greater than, use an open circle, because we're not saying that the value we plug in for the variable can be equal to the other value in our inequality. Any questions that you have, write them on the left-hand side and make sure to ask them when we connect. Big thing here is on my graph, I have an open circle because my inequality sign is either a greater than or a less than. I'm not saying that the other value is equal to. Let's go to example 5 and 6. Hold up. What is different about these two inequalities? Write them down on your paper and be thinking, what is different about the inequality in 5 and the inequality in number 6? Maybe you're thinking what's different, Miss Kluver, is that the variable is not coming first. And I would say you're right. It is much easier to understand inequalities when our variable, our unknown, is coming first. Here's the thing though, we gotta be careful because right now -5 is greater than x. That means x, whatever I plug in, has to be less than -5. So not only do my two terms there need to switch spots, because because I want my variable coming first. My inequality sign has to flip as well. So this inequality would read as x is less than -5. Now I'm ready to graph. Let's find -5 on the number line. It's going to be an open circle because I'm not saying whatever I plug in can equal -5 and be less than it. Just less than. So now I'm looking for all those values that are less than -5. I'm going to draw my line with my arrowhead out to the left. And you can see now my variable is coming first. My arrowheads match. Here's my inequality symbol. It's kind of like an arrowhead. It's matching my arrowhead on the graph. Whereas before, if I wouldn't have flipped my inequality sign as well, they wouldn't have matched. Let's look at number 6. We have 7 is less than x. It's a lot easier to work with inequalities when our variable is coming first. So let's have them switch spots. But we also need to flip our inequality sign. 7 is less than x. That means x is greater than 7. Now we're ready to graph. Let's put an open circle on 7, and we're talking about all values that are greater than 7, so it's going to shoot out to the right, my arrowhead there. Notice my inequality sign here is kind of like an arrowhead, and it's pointing right. Notice how my arrowhead on my graph is also pointing right. They match. That wouldn't have been true if I wouldn't have also flipped my inequality sign when I moved my terms in the inequality to have the variable coming first. So the big thing with example 5 and 6 is, what side of the inequality should the variable go? Fill this in your notes. The variable always goes on the left. And that's what we practiced here with example 5 and 6. The thing we really have to be mindful of is when we make our variable and our other terms switch spots, we also have to flip the inequality symbol.